All right, so what we've got going on today is we're learning 6 of the parent functions. Now you already know, let me just flip this over. You already know one parent function, which is y equals x. It is a line, okay? So you already know that parent function, and you don't have to write this one down, but it is a parent function that you already know. So we'll just go ahead and graph that. So how do you graph a line that's just y equals x? Well, you would graph the y-intercept, which is normally over here, and there's not one, so its y-intercept is at 0, 0. And then you would find more points by using the slope. The slope is in front of the x, and since there's not a number there, it's a 1. So my slope would go over 1, up 1, over 1, up 1, and same thing if I wanted to go down. So this is a parent function of a line. So what a parent function is the equation of any function without any transformations to it. So you're used to seeing y equals mx plus b. Well, that m is a slope, which is a transformation, and the b is a shift up or down. So that's why the parent function is just y equals x. It doesn't have any other letters in it. So that is the one that you know already, or one of the ones that you know already. Another one that you actually know already, because I forgot there are quite a few on here that you already know. We did this earlier in the year. Quadratic. Quadratic is another one that you know. Its nickname is a parabola. And the equation for it is y equals x squared. Now, just to make you a little bit more comfortable with function notation, we're going to do function notation for all of these. So the function notation for it is f of x, and then it's also x squared, because remember in function notation, the f of x just goes in place of the y. Okay? So you guys know, I hope you remember, that when we graph a quadratic, you start at the vertex, which for any general parabola is at 0, 0. So we can put that point on our graph, 0, 0. And then if we go over 1, we actually put 1 into our equation. So 1 squared would be 1. So a positive 1 would make it go up 1. Then if I went over 2, if I put 2 in here, 2 squared would be 4. And if I put 3 in here, 3 squared would be 9. So over 1, up 1, over 2, up 4, and over 3, up 9. Let me make sure I got on there. Yep. Okay. But what about the negative side? Well, can I put negative 1 in here and get an answer? Yeah. So left 1, because left is a negative direction, that would actually be negative 1. If I put negative 1 in here and I did negative 1 times negative 1, that also gives me positive 1. Now, if you did it in your calculator and just hit negative 1 and then squared, it would not do it correctly. It would do 1 squared and then make it negative, so it would give you negative 1. So if you're ever going to put a negative number into your calculator and square it or take it to any power, you need to put that number in parentheses before you do it. But over here, so now 2, if I put negative 2 in there, negative 2 times negative 2, or negative 2 squared is 4. And 3, negative 3 times negative 3 is 9. So I can graph these points also on here. And then my graph looks kind of like the letter U. Remember that it needs to be curved or rounded at the bottom and not pointy, because that would be a different one. Okay, so then domain. Domain, to get to the domain, we move from left to right. So if I'm moving from the left, the first thing I hit is an arrow, so that means infinity. And the last thing I hit is an arrow, which also means infinity. So for the domain of a parabola, it's all real numbers. So we make a capital R, and then we draw a line through it like a dollar sign. Okay, that stands for all real numbers, or you could write out all real numbers, whichever you feel like. Okay, so the range, so domain we go left to right, range we go bottom to top. So if I look at the bottom here, no graph, boom, there's the graph, 0. And then it goes up to, boom, arrows, so forever. So that means it starts at 0 and goes to forever. Well, range is y, And if it goes from 0, that needs to be my number I'm going to use. But if it goes forever, that means it's all the numbers bigger than 0, but it did actually start at 0, so that's why it needs the or equal to also. So it goes from 0 and up. Now you see all the rest of this stuff? Yeah, cross that off. We're not going to do it. We do this in other classes, and I just made the note sheet without taking anything off that we don't need. So there you go, extra stuff. Sorry about you. Okay, so that was a parent function you knew. This next one is a parent function that I'm not sure that you know or not. So somebody will have to tell me if you know. This is a square root, and sometimes we call it the eyebrow. And you'll see what I mean. Its equation is y equals square root of x. Its function notation is f of x equals square root of x. And it starts kind of like a parabola or a quadratic, same thing. You start at 0, 0. Okay. But now I want to put in numbers into here that I can actually take the square root of. So can I take the square root of 1? Yes. And if you put that in your calculator, you would see that the square root of 1 is 1. But do I want to put in 2? Can I take the square root of 2? Well, I can, but it gives me a decimal, and I just don't feel like dealing with that. Can I take the square root of 3? Again, a decimal. Square root of 4. Oh, there's one that'll give me an actual number. So if I put in square root of 4, it gives me 2. So 4, 2 is another point. So what is the next number on here that's a perfect square root? 9. So I'm going to put in 9, and I would get 3. So I can go over 9 and up 3. So there's those points. Okay, now let's talk about this. So the other one on parabola, the other one I did was left. So if I put in left 1, which would be negative 1, can I take the square root of negative 1? Well, I can, but that would give me I. So can I graph an I? Nope, I can't. So this is the only side of the square root that we graph, which is why we call it the eyebrow, because it's just one little piece of it. There's nothing over here or down in any of these other quadrants because they would be negative. So in any of these other quadrants, it would be negative. That's why we don't have it in the parent function. Now there could be a reflection here, and then it might be down here, or reflection on the y, and then it might be over here. So it can get reflected to be in those other quadrants, but just for the parent function's sake, it is not. Okay, so domain on this. So moving from left to right, nothing, boom. There at 0 is where it starts. So x, and it's going to start at 0. So that's why I use 0 as my number. And then it goes on here forever. So is it greater than, which would be on this side, or is it less than 0, which would be over here? Well, it's on the right. All these numbers right here are greater than 0, so that's why it's greater than 0. Range, start at the bottom, nothing, nothing, boom. There is my graph. So for range, it's y, and again, I start at 0. So is it all my numbers that are bigger than 0, so up here, or all my numbers that are smaller than 0, down there? Well, the graph is definitely up here, so it's greater than or equal to 0 is what your range is. So those are quadratic and square root. So x squared and square root of x. And you may have noticed something. Did anybody notice this? These points, over 1 up 1, over 2 up 4, over 3 up 9. What about these points? 1, 1, 4, 2, 9, 3. So what do you notice? Those are inverses. So really, if you memorize these ones, and then you just kind of memorize the shape of this, you know that these points backwards make this top eyebrow. So this is something that you are going to need to do tonight, and I really want you to try to, or whenever you do your homework, I really want you to try to graph these the second time you graph them without looking at your notes. See if you can get them without looking at your notes. So quadratic, and how did we get these numbers? Well, we just plugged in 1, 2, and 3, and we got 1, 4, and 9 as our answers. And then for square root, you just do the inverse, which means you flip your x and your y. Okay, next, another set of parent functions. So our next set of parent functions is going to be the cubic. Its equation is y equals x to the third, and its function is f of x equals x to the third. So to get cubic, we are still going to start at 0, 0. In fact, you will notice all but one of these start at 0, 0. So we're going to start plugging in numbers. So if I plug in 1, I take 1 and put it in here. So 1 to the third. So you can either get a calculator or use your brain. 1 times 1 times 1. That is going to give me 1. If I put in 2, 2 times 2 times 2, that is 8. If I put in 3, 3 times 3 times 3, that is 27. And that is already off my graph, so I'm going to stop there. So 0, 0 is my first point. 1, 1, 2, 8. What about left? Can we put a left in there? So -1 times -1 times -1. Well, the first two negatives would cancel, but that third negative would stay. So we would have -1. So negative is a down direction. So that's why these are going down instead of up, because they would be negative. Okay, so if we put in -2, -2 times -2 is +4. But if we multiplied by -2 again, we would get -8. So that's why it's pointing down. And then we could do the 327, but it's not going to be on our graph, so I'm just going to leave that off. So if we draw this in here, remember you cannot cross the next up and down line unless you have a point to go through. So the points are like the bridges that let you go through these vertical lines. Okay, so this goes way up and way down, and it's just kind of just a little squiggle there in the middle. So that's what its nickname is squiggle, because it's pretty straight except for that squiggle right there in the middle. Okay, now domain, to go from left to right. So left, I hit an arrow. Right, the last thing I hit is an arrow. So the domain is going to be arrow to arrow or infinity to infinity, so all real numbers. How about the range? First thing I hit is an arrow. Last thing I hit is an arrow. So same thing, range, all real numbers. So anything I put into this equation, I could get an answer out that I could graph. There wouldn't be anything imaginary. Okay, so next one we're going to do is cube root. And its equation is y equals a 3 in the index of x. And its function notation is, again, 3 in the index of x. And remember how we talked about quadratic and square root, how they were inverses? Well, cube root are inverses, is an inverse of cubic also. So we're going to start at 0, 0. But then we're going to take these points and reverse them. So 1, 1 isn't really going to change anything. Over 1, up 1. But then the next one, instead of being 2, 8, we're going to reverse it. So it's over 8, up 2. And we're going to put the 27 and 3 on there just to show you what it would be, even though that's not going to be graphed. So over 1, up 1, over 8, up 2. Well, what about the negatives? Well, remember on square root, we didn't have any negatives because we couldn't do the square root of those. But let's just see, can I do the cube root? Let me get a little light on this subject. Can I do the cube root of a negative number? Well, if I hit math, I can see that cube root is number 4. So if I just type in number 4, and I'm going to do negative 8, negative 8. So what is the cube root of negative 8? It's negative 2. So is this imaginary? No. So can we have a negative side when it's cube root? Yes, we can. So left 1, down 1, left 8, and we already saw that that was negative 2, so down 2. And then same thing with 27 and 3, but those aren't going to fit on there. So left 1, down 1. And if you tried in your calculator to do the cube root of 1, negative 1, it would give you negative 1. So you could check my work. So square root does not have a negative side, but cube root does because it has 3 negatives and only 2 of them would cancel and then just keep it negative. So it doesn't have an imaginary side. Okay, domain, left, arrow, to right, arrow, so all real numbers. Range, bottom, arrow, top, arrow, so all real numbers. And again, if you can memorize cubic, cube root is the inverse. So you just need to memorize quadratic and know square root is the inverse, and then memorize cubic and know that cube root is the inverse. So I've already kind of cut your work in half on knowing how to graph these. We have two more, one more that you know and one more that you don't know. So we're going to start with the one that you do know. Absolute value. Absolute value, hopefully you remember, this one makes the letter V. Its equation is y equals x inside these bars like a jail, and f of x with the x inside the absolute value bars. Now, make sure you know that those are absolute value bars, not the number 1 or the letter L or anything like that. Keys to graphing. This one looks pretty similar to a parabola. We're going to start at 0, 0, and then we go over 1. And remember, when you put anything into your absolute value, it makes it positive. So we'd go up 1, over 2, up 2, over 3, up 3. So it's 0, 0, and then we got 1, 1, 2, 2, 3, 3. Now, does this have a negative sign? Well, if I put negative 1, which is left is a negative direction, if I put negative 1 into the absolute value, it would give me positive 1. What do you think about negative 2? Also positive 2. How about negative 3? Also positive 3, and etc., etc. But we're going to stop there because we can. No need to go on and on and on. So if you notice, this makes a pretty straight line. It should go straight out to 10, 10, and then we put an arrow on it. And this one over here. Okay, straight out to 10, 10. So we put an arrow on it. So make sure you're taking all of these out to the edge of your graphs and then putting arrows on them, because they do go on and on and on, except square root is the only one that doesn't have arrows, and it only has one arrow. Domain on this guy, so left to right, arrow to arrow. So just like quadratic, its domain is all real numbers. It's a really bad R. Range. Is there any graph down here? No. And the first thing I hit right here is not an arrow. It's the number 0. So for range, we use Y, and our graph starts at 0, and then it goes on forever. So it's all the numbers that are greater than or equal to 0, and we have to use the or equal to because it actually touches 0. Okay, last one. And this one is the only one that has two branches. So this is called the reciprocal, or some people call it the rational function. Its nickname is the swoopty swoopty. Swoopty swoopty. It's fun to say. Try it. Its equation is a fraction, and rational is a fancy math word for fraction. So if you knew that rational was a fancy math word for fraction, you were probably waiting for that fraction to show up. If you didn't, now you know. The more you know, deal with it. Okay, so this one is kind of the odd one in the bunch. It does not exactly start at 0. You kind of started at 0, but what you do is you start at the black hole. And no, we didn't just name that because it's my last name. But you start at the black hole with force field lines, which are asymptotes. So start at the black hole with force field lines, which are asymptotes. So your black hole is at 0, 0 unless it gets translated. So we're going to put an empty dot, an empty circle on 0, 0, and draw in, and it's hard to see them, because they're on these bolded lines, but draw up and down these force field lines. They are the asymptotes. So hopefully you remember from asymptotes that we've graphed in the past that the graph can get really, really close to the asymptote, but it cannot touch it and it cannot cross it. So now let's get some numbers in here. So if I put in 1, if I put in 1 for my x, it would be 1 over 1. Well, 1 over 1 is 1. So 1, 1 is my first point. Let's say I put in 2. Well, that would be 1 over 2. So that would be 1/2. So we go over 2 and up 1/2. Now, if I put in 3, I'm just going to get 1/3, 1/4, 1/5, 1/6, right? So you can see that this is getting closer and closer and closer to my line, because like this one would be clear down at 1/10, which I wouldn't even attempt to graph, but it will not, remember, touch or cross these asymptotes. So I know that this is getting closer and closer and closer, but what about, what's it doing up here? Well, let's try. This is also called the reciprocal graph because 2 and 1/2 are reciprocals. So I can also go over 1/2 and up 2 because they're reciprocals. And it's called the reciprocal graph. So I could also go over 1/3 and up 3, or 1/4 and up 4. So basically whatever you would do on this side, you would do the opposite on that side. So you'd go over the fraction and up that amount. So we can draw these in, remember getting closer and closer, closer and closer to that line, but do not touch or cross it. And it's very, very, very important that your branches keep getting closer and closer to that line and they don't do something crazy like, I'm going to draw on this, maybe if that's, oh no, that pin is not the one that's working. Make sure they don't do something like that, like where they're going back in, making more like a C. They need to make more of an L. Or like if you were driving down the road and you're turning, you don't go into the grass. You make a smooth curve, turn. Hopefully you're making a smooth turn as you're driving. So then down here, we have these same points, but to the left and down, because if we put -1 in here, it'd be -1. So, nope, not right, Mrs. Black. Left 1, down 1, left 2, down 1/2, and left 1/2, down 2. So those same points. And if you feel like it, you could do over 1/3 and down 3, or over 3 and down 1/3. Let's see how well I can draw this. Okay, that wasn't too bad. But again, get closer and closer to those lines. Don't bounce off of them and come back into this graph. Okay, so those are the 6 parent functions that we are going to expect you to know. And that is it for this video. Good luck and let us know how we can help you.